Purves. I'm here today to talk about the company I work for, Loowatt. We're a company in the business of sanitation, as you might expect, and we are designing a new waterless toilet, which is almost ready for manufacture. The toilet uses biodegradable film, and we also do some research into fecal sludge management and business models as I'll explain. So, outline of the presentation. What we do, what Loowatt does, and how we operate. Our pilot project in Madagascar, in the capital city, that's really the focus of the presentation. The work conducted so far, so we're at a point about midway through the pilot. We've just finished constructing, but we've got some interesting results already. Key findings that we have so far. The implications of those findings for scaling our technology in this context. Implications for the groups and acknowledgements. So our approach as a business really focuses on three areas, and this has been touched upon today a few times already. So we need a toilet that people want to use. We need a service. So what we're doing is designing a new waterless toilet. It's aspirational, it's odorless. It takes the form factor of a sit toilet. And it's based on a simple mechanical mechanism inside, and it uses biodegradable film to seal human waste in a completely odorless fashion. On top of that, we're looking at value generation. That's what we're all about. We need to generate as much value as we can from that captured human waste in one way or another, and there are many options. So making smart choices on your fecal sludge management technology is key. In order to maximise that value. So we're looking into that at the moment. We're doing some of our own work into that area as well. And modelling, so economic modelling, financial modelling of the system, the chosen implementation strategy is of course crucial. You need to understand how much is it going to cost up front, how much is it going to cost to run, and how much revenue you're going to generate, and also depreciation. And once you know that, and you can be confident about that, then you can be confident about scaling. And also cultural modelling, so really understanding the dynamics of culture surrounding your implementation. Market research approach means that we can create a more robust solution and an idea for scaling the technology. So our Madagascar pilot is really, these are the key objectives. So it's understanding local culture, preferences and need surrounding sanitation. Getting feedback on our physical products, the Loowatt toilet. We have a digester as well, so we need to understand how our operators are going to feel about using a digester, how it's going to physically operate, and other equipment. To validate our financial modelling through surveying, through data collection, understanding are our products as valuable as we think they are, is the demand there for the products, and measuring the value, same thing. Value potential of those system commodities. So our pilot location is in the capital city of Madagascar, Antananarivo. It's a very densely populated area northwest of the city centre called Fami. There's about 13,000 residents there. It's an incredibly poor area, very low access to sanitation. And even though it looks like there's farmland and there's lovely fields, they're actually just, it's waterlogged areas, you can't go in, it's completely polluted. So actually all the settlement is concentrated along those roads, you can see, and it's extremely dense. And also the water table is very high, so it's a pretty difficult area to work in, which I think is another reason why our technology fits in this area, because pit latrines are just a huge problem there. People try their best, but they fill up in no time. A flood comes along and it washes the waste everywhere. And also they've completely run out of space to dig pit latrines now. So they move them every year, but they've just completely filled up the land. So our implementation model, I wish I had a laser pointer, starts off with the users. So we're aiming to serve about 50 users with our main facility, which we've called the energy unit. And the energy unit contains a number of Loowatt toilets, but at the moment we're focusing on one toilet in the energy unit, combined with an anaerobic digester, so we're producing gas on site. And that means that the energy that we produce is already distributed in the community. The key thing about the digestion being on site is that pathogens are reduced by about 90% or more potentially by the digestion process, which means that transport of that waste is then much safer through the narrow streets. So once we have, thank you. So yeah, here's the energy unit. So we have a toilet there, digester there, we have some gas storage, and we have facilities to make use of the biogas, so to make products from the gas effectively. And those products could be cooking, lighting, take-home lighting products, for example, charging mobile phones, or even having a hot shower facility on site or selling hot water to take home. And so these benefits go back to the users, and the users pay for these as well, so these are products which are paid for. The other output of the energy unit is digestate from the digester, which is transported not so far, but a few hundred meters to the edge of the community where there's a little bit more space, mixed with some dry organic materials such as straw, and then we go through a thermophilic composting process. So that's the crucial step in all this really, is to kill the pathogens, and we're aiming to conform to EPA biosolids regulations on that. And then followed by that is a vermicomposting process. So the idea of the vermicomposting is to upgrade the composting to a high-grade, very valuable, very attractive product. And then that fertilizer is not quite sold back to the users, but it's sold to local farmers. So part of the work we've done so far, we've constructed the body of our toilet locally for a number of reasons. So first and foremost is we want to put that manufacturing locally, we want to create jobs, we want to create positive externalities. But it's also just cost effective. At the moment especially, we don't have, as Andy does, a big steel tool to churn out 100,000 bodies. But we can have one of these concrete bodies made locally pretty cheaply. Yeah, so we've been doing that, that's great. Oh, and by the way, the mechanism is developed in the UK and it's made in the UK at the moment, but we hope to, in the future, move some of that manufacturing out to where the toilets are bought. We've also constructed an anaerobic digester. As Andy alluded to, it's reasonably difficult to find just the right digester solution. And we found that with limited space, we needed to create our own digester. There just wasn't that product there. But working with a local boats manufacturer, we were able to make this incredibly high quality piece of equipment. It was absolutely amazing. And we've incorporated some heating because we want to increase the gas output. Because the climate in Madagascar is cooler than you might expect. It's average about 18 degrees so in the central plain. So we want to boost that up to about 30 degrees to get a lot more gas production and reduce the size of the digester. And this is the finished digester here in the bottom right. And so the energy unit, which contains the toilet, a cabin for the attendant, sorry, I forgot to explain that. So the energy unit would be owned and operated by perhaps an entrepreneur who would look after facilities, charge for toilet uses. So we have a toilet in there, as you can see, that's the one we've had made locally. And I mean, I hope you think as well that it looks pretty nice. It looks like a toilet I would probably want to use myself, and I think that's really what we're aiming for. We're trying to provide high quality services that people really aspire to use. Because ultimately, I feel that people will want to pay for using a toilet with a great experience, without any odour, and in an aspirational form factor. And this is our pilot compost factory, which is really just the base. At the moment, we're just starting our composting, and it's kind of acting as a base for some experimentation on that process. We have Dr. Claire Furlong, who's an expert in vermicomposting and composting, and with human waste. She's out there now in Madagascar, and she's designing that process for us, and she's getting the worm cultivation up and going. So. The other key piece of work we've done so far is a cultural and economic survey locally covering households, so background data, socio-economic, sanitation status quo, so, you know, do people have toilets, do they even use a toilet, do they pay to use toilets? Energy and technology use an example, so do people have mobiles, how often do they charge them, how much do they pay to charge their mobiles, but a whole host of questions, many questions, but also focused questions on our system, so response, I mean, probably the most important thing, response to human waste derived products, so any product that came from human waste, even electricity, is conceivably something that is outside of someone's moral compass, and they would think, oh, I'd never buy it. And we did find that. We found about 5% of people didn't even want to use electricity that was made from biogas. But in general, the responses were very positive. So we need organic waste to support the digestion process. So we thought, well, is that going to be available locally? Let's find out. So we surveyed waste collectors and also local people to find out how much organic waste they produce. And it turns out there's plenty enough available, surprisingly. And also farmers, so we need to find out what's the market for our fertiliser, what are the usage characteristics of fertiliser, and also to gauge a response to a sample of Loowatt fertiliser and the fact that it's human waste derived as well, and to gauge a price point. So once we have all that information, we can then make a reasonable estimate as to how much revenue we might be able to generate. So some key findings from that survey. Toilet preference, undecided, 30 people, not really sure whether I like sit or squat. Squat, only 5% preferred squat, despite that being by far the most prevalent type of toilet in the area, and with 65% preference for sit. And there are sit toilets in Madagascar, in the capital, but they're only really owned by wealthy people, so I think it just backs up that idea of the aspirational side of things, and it backs up what we've decided to do with our toilet. And responses to human waste derived products, so we have cooking, 53%. It's interesting because how closely the gas is connected to that product. If it's very closely connected, people aren't so sure about using it. But if it's, you know, a bit more distantly connected, then they're more willing to try it. So cooking, for example, is, you know, somewhat close, you know, the gas is close to your food. So 53%, which is still positive, very positive. Heating water, 60%, and electricity, 85%. And for fertiliser, so this is would local people consume products grown from human waste derived fertiliser. In the case of vegetables, which came directly in contact with that fertiliser, 50%. Fruit from trees, 68%, and flowers, 93%. So we consider that to be a very positive result, and we see that supporting our case for scaling. And also commodity product values, so the human waste derived products, how much are they worth? To the toilet use isn't exactly human waste derived, but so to use a toilet to defecate, 4.4 cents average response, to pee, 2.2%, 2.2 cents. But that corresponds to local norms because there are already many public toilet facilities and they generally have that tariff, so that's kind of in the social consciousness already. And actually people are already used to paying for toilets and having public toilets, so we're quite confident that our facility will be well received. Mobile charges, 9.1 cents per charge. Hot water, 10 litres. This was kind of a surprise for us because it's something we hadn't really considered. Take-home hot water product from the gas, 5.5 cents for 10 litres. And fertiliser, which is quite incredible response from the farmers we surveyed. After seeing a sample, in fact, what's also interesting, 100% of those farmers said they would be willing to use this fertiliser, knowing, you know, after we explained where it came from, after having seen a sample. So before they'd seen a sample, it was something like 80%, I think, or 85%. And after they'd seen a sample, which was a high-grade quality fertiliser, which we're aiming for, it was 100%. So that's interesting. I think it kind of shows that cultural barriers are perhaps lower than expected. And yeah, the price of fertiliser, 83 cents per kilogram, sounds absolutely balmy, but that's the response we had. And that's because farmers know full well the value of fertiliser, and they already buy inorganic fertiliser. So, and also there are similar products on the market already, vermicompost in the area, which sell for a similar amount. So we're using a 50 cent per kilogram assumption in our modelling to provide a safety factor. So implications for scaling the technology. So the cultural aspirations of the community we're in seem to align with what we're trying to provide, products and services. Responses to human waste-derived products are overwhelmingly positive, really, and we don't see that being a problem with the products we've decided to try and sell. And the price points and demand support the economic case. Got the numbers written down. So our scaled case, not quite the same as the scales you guys are talking about, but 55 energy units is our scaled case in this context, is what we're aiming for in this community. And at that scale, we expect to make about $2 profit at the energy unit. That's on top of the salary for the operator. And the compost facility, which serves those 55 energy units, we expect to be producing about $500 a day revenue, which works out to be $10 a day per toilet. But it's worth bearing in mind that that's based on our research and our surveying, which is one thing. And in the next 6 months, we're going to be testing those things for real. And we're going to be selling that fertiliser, so we'll find out. So yeah, the basic conclusion of it is the results we have so far are positive, and they support the case for continued work in this area for Loowatt. I would like to thank Bill and Melinda Gates Foundation, What's Up, Andy for his support as well during the pilot project. Innovation RCA is a business incubator we're part of in London, and USAID.